Hello, everyone, to the Research VR podcast. I figured I'd start doing intros like this, the same way we did for the last episode, where either I can introduce the guest or also let you know about things beyond the content of this episode. So the things I want to tell you about this week are about the fact that we upload these podcasts also to YouTube, in case you like to listen to podcasts on YouTube, where there are nice timestamps where you could actually click on the question that I asked that's timestamped in the description, and it'll jump straight to that part of the video. Of course, unfortunately for now, we still don't do video podcasts. That's just a lot of overhead. And, at some point, I would like to do that, but once we get a proper kind of workflow and pipeline down, that doesn't add too much more time than audio podcasts already take. And I wanted to also mention the fact that we have a Patreon where you can pay per episode, basically. Instead of per month, it's not just the subscription that you're paying for endlessly, but every time we release an episode, you can contribute $5 to the podcast. So beyond that, I want to also briefly apologize for the audio quality, at least my audio quality in this episode. I had some new equipment in the room and I hadn't set it up properly. So I run a little bit hot, but thankfully the guest, Jeff Powers, his mic on the Valve Index sounded incredible. And we also started doing the podcast, having the podcast recordings in VR again. We haven't been doing that for the last year or two, but we're starting to use Mozilla Hubs. So let's see how well that works. So far, I've done 2 recordings, and they've been quite well. This podcast is a really interesting episode to listen to if you're interested to hear about the Apple LIDAR sensor and kind of how that works and where that fits, as well as Jeff Powers just talking about depth cameras and the structure sensor that he's known for building and the company that he co-founded. So, we also talk about working with Valve and about how they created the Room View 3D feature that's now shipped for all Valve Index headsets. So yeah, it's pretty well packed. Enjoy it, and we'll see you at the next episode. Hello, everyone, and welcome back to the Research VR podcast, the podcast behind the science and design of virtual reality. I'm your host, Azad Balabanyan, and with me today is special guest Jeff Powers, the former CEO of Occipital and the current CEO of Arcturus Industries. Hi, Jeff.
Hi, great to be here.
Yeah, thank you for being here. Today in this episode, we're going to be talking about Occipital, the structure sensor, or in more particular detail, like active depth cameras. We're going to be most likely talking about like photogrammetry, reconstructions, and of course, probably the latest project that you've been working on at Arcturus which has been the SteamVR Room View 3D, which you've developed alongside with Valve on bringing, I guess, not a stereo pass-through into the index, but more, how would you describe it? Like a 3D reconstruction view of your room?
Yeah, it's sort of a viewpoint corrected pass-through video. So the cameras on the headset are not at the correct eye position of the user, and we correct for that using 3D reconstruction.
Got it. So welcome to the podcast.
Yeah.
Okay, the Occipital structure sensor, that was, correct me if I'm wrong, that's probably one of the first like depth sensors that were available to consumers and developers, right? Back in 2013, 2014?
Yeah, we announced it in 2013. We started shipping to the first Kickstarter backers towards the end of 2013, early 2014. At the time, we called it the first depth sensor for mobile devices, and that was correct. Like, we even beat other projects like Google Tango to the market. So we had basically the first mobile depth camera that was out, and of course, there's been a lot that has evolved since then, but still remains one of the best ways to do depth on mobile.
Sure. And I guess what was the landscape like at the time? You said you were launched before Google Tango and a few other devices, but like, what if you were a developer wanting to build a robot that had any sense of depth in front of it? Like, what were other options that they could have done before the depth sensor?
Well, the Kinect was our big inspiration, and it was available at the time. It was bulky. Still is. But
Sure.
the Connect was the big thing that was out, that was actually at a, consumer professional price point. Besides the Connect, you had you had expensive stereo rigs, industrial grade sort of cameras, people running stereo reconstructions on, live stereo on host processors, which of course was pretty compute heavy. You of course had LIDAR systems at the time, but they were really the sort of scanning LIDAR that was used to scan, a $10,000 scanning LIDAR to scan an interior of a, to scan like an exterior for surveying purposes, things like that.
Mm-hmm.
That's kind of what you had at the time. And like I said, the Connect was the big breakthrough. It was the moment where we all realized, oh, this stuff doesn't need to be crazy expensive. This is truly a new kind of input that we can leverage. And that was our inspiration. But it wasn't available for mobile. It was something that you had to plug into a desktop.
So the structure sensor, when it first came out, was that entirely based around mobile devices, or did you mean it that initially was a PC?
What was intended
device?
to be special about it was that it was for mobile. Like the fact that you could attach it to an iPad was the kind of the breakthrough. It wasn't just that. Like we also made a nice SDK to allow people to do live reconstructions and things like that. But until then, you didn't really have the pairing of, a mobile device that you can easily use to walk around an object if you're capturing it, whether that's, part of a room, whether that's part of a person, all sorts of different things were scanned. Until then, you were kind of like, if you were using a Connect, you were plugging a Connect into a PC. It was quite large and bulky. And then you were trying to like walk around an object while dangling a cord. And this was quite difficult, right? And so that was the big thing we were trying to solve, is now you can actually see on a mobile screen what you're capturing while you're scanning. And so, it was actually intended to be mobile, was one of the big advantages. Eventually, we, of course, supported things that were not mobile, but the mobile was the big aspect.
And you picked mobile specifically because of the portability or the live reconstruction aspect, or like why? It seems like perhaps it was kind of a big risk to take on mobile, but did you see it working out because pretty much all the other sensors weren't targeting that?
Yeah, I think the product was a success because of the new user experiences that were possible on mobile. One of the big applications that took off for structure sensor was the use of structure sensor to do scanning for orthotics and prosthetics and things like that. That was much easier to do with a mobile device than a PC attached scanner. Not
sure.
The PC side is more it's more difficult to set up and use. It's just more overhead, right? Instead of just launching an app on your home screen, you're sort of, it sounds silly, but you need to install something. You need to update it. You need to, maintain all your system updates and all these aspects that just made it difficult for companies to, deploy a non-mobile solution. And of course, then there's also the user experience aspect where if you're, again, dangling a cord attached to a PC, it just wasn't as simple. So in the end, it was able to affect markets like orthotics and prosthetics, where an easy to use, easy to set up, easy to see what you're doing scan experience was actually the key ingredient that made it a big win.
Right. And from the applications that I've seen, like real estate or construction kind of seems to be a big target. And for that, I guess portability is kind of everything, right? A real estate agent is not going to carry around a laptop even to do reconstruction, or a construction person isn't going to either. Yeah,
that's an even maybe better example, which is, once you start to do something like, a home capture, like a home service professional or a real estate person wanting to digitize a client's space, you're not going to lug a desktop into their space, and even a laptop is kind of pretty clunky. So it kind of needs to be mobile. A tablet is, acceptable. A phone is maybe even better, but yeah, it's critical to be mobile. And so we were out ahead of the game with that, and was successful. And then I think as we see now, like, maybe 7 years later, the market's catching up, right? And you're starting to see mobile depth really take off in a way that we knew it would, but it took a lot longer than we thought it was going to take.
How, like, can you perhaps talk a little bit about that? Were you expecting more advancements on the hardware side for phones to have, how did you see things playing out?
Yeah, we did expect that would happen faster. We thought that, we didn't think it would be 7 years before we saw, a mobile depth camera that was, ubiquitous, pervasive. Now we're starting to finally see that. Like, Apple just launched the LIDAR sensor in the iPad, and of course, it's very likely that's going to show up in the next phone. So at that point, you're going to have hundreds of millions of devices out there, and a vibrant developer community. Instead, what we got was, Google made a valiant effort with Tango, but it never really went anywhere. It's tough for a project like that inside of a company like Google to continue, because the expectation of anything inside of a company of that scale is you have to make billions of dollars, and if you're not making billions of dollars, you're going to get cut. And so, they made it a while, but they ultimately kind of gave up on that. All the other, mobile device makers, there's not a lot of, like, for the ways I'm frustrated about Apple, I'd say they do have courage more than a lot of these other companies do. And they will, Tim Cook courage.
Yeah, that's their word. Yeah.
It's true in a sense. They also have a lot of other traits that aren't so good, but they have this courage to go ahead and say, yep, we're going to do this, and we're going to do it right. And we're going to stick to it. We're not going to, like, throw a little thing over the wall and then realize, like, oh, no, okay, not that many developers used it. Okay, shut it down, right? And throw that effort away. They're going to persist. And so because of that, and even just because of that track record, now developers can rely on that system. And so I think now we're going to start to see a massive amount of developers actually using mobile depth, whereas before it was just too risky. It was too risky to bet your whole company on, whatever, like some random, Tango powered phone that, is probably going to be dead in 18 months, right? Now you can sort of say, I'll support these Apple APIs, and I know they're going to be around for 10 years. That's the difference now.
And with the structure sensor, were you hoping for other companies to kind of actually build around your ecosystem and to kind of like find their own application and then like double down on serving that specific use case? And perhaps did you see things like that happening?
Yeah, you mean in terms of third-party developers and stuff like that? We did. We saw literally maybe close to 150 companies so far have built basically their whole company around structure sensor, around that kind of mobile depth. We also saw the research community do a lot of fundamental work with structure sensor. There's this data set called ScanNet that was built at Stanford that used structure sensor. And it was critical because they could get around mobile, just like we were talking about, and explore all these spaces and build one of the first data sets, I think, of over 1,000, maybe 1,300 scans of really diverse set of indoor environments. Just couldn't really do it any other way. So we saw the research community doing a lot. We saw hundreds of companies building, really their company around this. Now, those are mostly smaller, startups doing smaller applications targeting, niche verticals, like I mentioned medical, some things in, home improvement, real estate, things like that. But we did see a pretty satisfying adoption. We didn't just build an SDK and then nobody showed up. Like we literally had hundreds of companies showing up and, creating a difference in a number of markets.
Yeah. Nowadays, I think the last time I was looking at the structure sensor was when I was looking at building myself a Leap Motion Project North. North Star. Yeah. because it's a open source headset, and you kind of need to put together the modules. And so for positional tracking, there's a couple of different options, whether it's the RealSense or I think perhaps like the Stereolab Z camera is another option. So that led me also into looking into the Structure Core, which now is the kind of a standalone device. Basically, it's just your tracking system and the hardware that can be integrated into any hardware beyond like mobile devices. Correct? Yeah,
exactly. And Structure Core was trying to branch out beyond just the mobile device attachment and make this available more broadly, as you said. So it has enough sensory inputs now that it doesn't rely on working in tandem with the mobile device. It has its own visible camera. It has its own IMU. So it can do a full 6DoF scanning and tracking on its own. It still needs compute to help it out, but that can be mobile compute, that can be desktop compute. It's pretty whatever you want. And so that makes it a particularly good fit for something like North Star, where you don't have an existing phone or tablet. You're providing your own compute puck, essentially, using an Intel NUC or whatever it might be.
In terms of picking between, like, so at some point you had to make a guess or kind of a prediction whether single camera SLAM would become good enough that itself, like a single camera, would be necessary, or you could go the active depth sensor route, right? Or with multiple cameras, or with an IR projector and camera. How have you kind of seen that play out? Because I'm sure like early 2010s, that was kind of the conversation, I'm sure, on the research side. And you had to make a bet on that. And you're also seeing this still kind of being debated on the self-driving car side, whether it's LIDAR or camera and radars are good enough. How did you approach like a question like that? And do you think, things worked out as you had hoped?
It's really interesting. I mean, we started out assuming that, we had to solve the problem with a monocular camera on devices that people already had. And so our very first work, after we raised a round of funding, was on trying to do this on a smartphone. And I still remember, at first we... I still kind of vividly remember some of the experiments where we were, prior to this, getting back into spatial computing. I mean, I won't go into the whole history, but at first we had this vision of doing essentially an AR engine far before anything like ARKit or ARCore existed. We didn't actually have a lot of support from mentors and investors and so on. It just wasn't a pitch that people understood at the time. Hindsight's 2020. Maybe we should have actually built that kind of a system just using monocular cameras, 5 or 6 years before others did. But we didn't. We sort of followed market feedback. We ended up doing some stuff like barcode recognition. But at some point in 2011, late 2011, we actually started working on an AR engine for real. And we quickly realized that even, the camera quality was not very good, and the compute was extremely limited as well. And so around that time frame, which is like the second, third generation of the iPhone, you could not do this kind of stuff on the phone. Like the camera wasn't good. It was noisy. It had a lot of rolling shutter problems, and the compute just wasn't there. And so at the time, you could have done a very restricted kind of AR engine, or you could maybe take the path that we took, which was to actually augment it and solve a little bit with hardware. But it's been a very interesting, 9 years since then, where we've seen the push and pull happen. It's like you actually have, on one hand, the compute getting better. You have the sensors getting better. And then you have the cost of these special 3D sensors also coming down as well. So you kind of have all these three things, and like one thing will sort of jockey ahead. Like you'll have the compute just really push forward with like the introduction of like a neural engine on a chip, and then software people will say, oh, well, we can actually use that neural engine and these other compute elements to actually basically just infer depth out of nowhere. And then, and then the hardware guys will say, well, that's ridiculous. We can literally just sense this. And we can do it with, 3 millimeters of space. And it's like, okay, let's do that. And so you're seeing these different things jockeying. And I think that you're not actually going to see, I think that's going to continue for another decade. I think you're not going to have it where, oh, well, we decided one year that turns out it was just monocular cameras. That's the way we're going to go. Like, it's not going to be that. I think you are going to see, I think, the number of sensors increasing. But then at the end of the day, are we using, active sensing, or are we using deep learning and monocular sensing? Yes. Like, right?
Sure.
And that's I think how it's gonna play out is this myriad of different options and the application dictating what choices are made in a particular context.
Right. I guess the reason I asked that is because looking at Google and ARCore Tango, when they kind of went away from Tango, it felt like they did sort of make a choice as to what they saw the future of it being. And I guess that makes sense. It would be especially with Android phones having such a wide range of prices, requiring a new kind of sensing unit on even low end phones would probably be just economically unfeasible.
Yeah.
And maybe they also saw that monocular SLAM was becoming good enough that they could ship things with that. But you're saying there's still a huge variety of applications where that doesn't work, or that you would want higher precision and accuracy.
Yeah, I think we're not going to see the race being won and where there's just no depth cameras in the future, or vice versa, where we only use depth cameras. I think that we're going to see a hybrid. But to your point, actually, for Google, it makes total sense because they have to support this diversity of devices. And especially at the time, there hadn't been any proven major wins with active depth. And so the OEMs were like, well, yeah, we did that project and it didn't do nearly as well as our flagship phone where, all we did was made the, camera better. And so we should put our dollars into that. And of course, that's how that played out for a while. But, over a longer arc, you're going to see these, miniaturized sensors show up and you're going to see the cost go way, way down. And all of a sudden, it's going to be way more feasible. And people have figured out now how to use them for things like taking better photos. And so you're going to see them probably hybridize and come in. But I think it is key, though. I think we're going to see a world where the algorithms need to work kind of regardless of what the inputs are, and the quality just varies depending on the input. And so you're going to have APIs that compute depth, whether there's a depth camera or whether there isn't. And developers are going to be able to target those same APIs, and it'll just perform better on one device than another, rather than like not work at all on one device.
Sure. They're not two separate, completely different systems, but it's like one software API that can take in multiple inputs, whether it's just cameras or depth or LIDAR even. And
yeah. So your perception layer, and that perception layer is going to have various fidelity depending on your hardware, but you're still going to have, the ability to compute depth regardless. You're going to have the ability to compute position and tracking. And you're going to have semantics regardless. So you're going to have all these things regardless of what the sensory inputs are. And then, if you're somebody who's like, I absolutely have to have the best quality tracking, you might go for this hardware over another one. I think that's how it's going to play out.
Fair. Is Occipital, or perhaps kind of is Canvas the software layer of structure? Is that, if I'm understanding that correctly?
Occipital is definitely, pivoting a little bit more towards software, which was actually the vision from the beginning. I mean, if you go back to why we decided to build hardware, you look at our pitch decks, we've never released them, but basically the pitch was, this is going to happen. And so let's build the hardware so that our software can be ahead of the curve when the hardware shows up. Turns out it took way longer than we expected. Turned out we spent way more time on the hardware side, but that was the vision. And so Canvas is actually the software side of Occipital. It's the software effort into, capturing, using, and practically using indoor spaces. Now, it is a bit specific to indoor spaces and applications like home improvement and perhaps real estate and measuring and perhaps insurance, things like that. It's a bit specific to that. The reason that it's specific to that is, to succeed, I think you need to focus and you need to have like kind of a vertical focus. And if we tried, if Occipital tried to say, we're going to boil the ocean and solve every problem, whether it's photogrammetry for games, whether it's, professionals using it for measuring, it would just be too fractured. But that said, the technology is quite general, and I'm excited to see people use Canvas stuff for things that Occipital never thought they would use it for, right? To use it for something in VR, to use it for something, for training, things like that. I think that's going to happen. But yeah, the company's really focused, Canvas team's really focused on, all these home improvement use cases. And can we make it easier for consumers to capture their space, send it to professionals? Can we make it so that basically in the future, whenever you do any kind of improvement project in your home, whether it's purchasing a few items to renovating the space, you always start with a scan. Like that's what you should do. You shouldn't start with, sketching in 2D. You shouldn't start with just scratching your head and being confused. You should just ingest the space and then start to work with it. And Canvas is the system to do that.
Yeah, I am, funnily enough, now starting to do that with my newly purchased 3D printer and like learning how to build things and learning some CAD. I'm more proficient on the photogrammetry side, but to scan small things, I need to make sure things are scaled and with like active depth. Like that's not really an issue. That's all. The scale is always correct. You can just perhaps import the mesh and just start to kind of like build around the mesh, and then print those and then have that perfectly fit into the part of your home that you want to have that thing fit into.
Yeah.
I think.
Exactly. Yeah. And the realization that we had there is that, photogrammetry and meshing and reconstruction is stage one, but you ultimately need to be able to edit. It's very hard to edit a mesh, right? I mean, you can, but you have to be really skilled. You have to have the right tools. It's very difficult, but you can edit a CAD representation, right? So the key is in the near future, we need the ability for someone to take their phone, really, just pan around a room or their entire home, and then actually get out of that CAD representation that they can edit, or that a professional can edit. If you give a professional, architect a 18 million polygon mesh, she's going to say, "What the hell is this?" Right? Right. This won't load. I have no idea what this is. I'm going to come and measure with my paper and, measuring tape. So.
Is that sort of CAD conversion a reality today?
It is. I mean, that's kind of the big thing that Canvas does, is that it actually does let you do that. Now, it's not 100% automated, so there's a service that Occipital provides to let you do that for a really nominal cost. And it also serves as the business model for Canvas, which is sort of a per scan fee. But what you're getting for that is you're getting this CAD conversion. You're getting the automated reconstruction part, which you can use in all the ways you can use that. Also getting the CAD conversion. And the CAD conversion is increasingly being automated, to the point that, someday, and hopefully not too far from now, you'll have, the possibility that an average, homeowner, renter can scan their space and then literally within minutes have an editable version of that space, or, be able to send that model, anonymize that and then send it to, a home service brand that you're comfortable with, and they'll maybe instantaneously and automatically quote you on something. They'll say, "Oh, well, thanks for that, anonymized version of your living room. Here's a quick render of what it would look like if we redid the flooring, and here's the quote. And by the way, it's binding." So, I mean, that's not a possibility right now today. Like, you have to go through all these hoops to get to that. But, a couple of years from now, that could be a reality where it's literally automatic, and nobody will have any more excuses of why they didn't do their home improvement projects.
Fair enough. I want to go back to asking you about hardware, because I know very few people that can talk about kind of like the depth sensors, about perhaps like LIDAR and the costs of building hardware. Are active depth sensors cheap to make or mass produce onto devices, phones? I mean, what was it like when the structure, first sensor you were designing and thinking what to add in there, and perhaps what has changed since then?
Yeah. I mean, the cost of hardware is a thing that, that it's hard to, a lot of people don't understand. There's very few things out there that are actually very expensive to make in very high volume, but almost everything is very expensive to make in low volume. And, to be able to make the structure sensor, there was just a huge amount of effort that went into building a production line that could actually test all of the different aspects of the system. If you're only going to build 10, you can do that by hand, right? You can give a person a PDF that says, follow this procedure. And, if it's wrong, we'll just RMA it and fix it. But if it's at scale, every aspect of that has to be automated. And also the same cost structure carries all the way down to your end suppliers as well. So the people that are making the little camera modules that you put into your sensor, the people that are making, the light emitters and so on, they also need to, if you're asking them to make 10, it's very costly for them to make each one. If you're asking them to make millions, it's very low cost. And so the problem that we've faced in this, emerging market is we didn't have the volumes to get the low prices. But then if you don't have the low prices, you can't get the volumes. So you have this chicken and egg problem where, developers and so on will say, well, I can't develop to that because it's not $10. And then you'll say, cool, well, can you commit to buying 50 million? In which case it'll be $10. And then, oh, no, of course not. I'll commit to 10. So that's the problem. And so, and then the costs of hardware become exponentially higher when you start to work with, custom elements at the lowest levels. So if you're building a brand new lens, if you're building, if you're using, like diffraction holography technologies to do your projector very small, if you're using a custom laser emitter because, the packages available just don't fit what you need, now you're talking about upfront setup costs for each and every one of those things into the, tens to hundreds of thousands of dollars to millions of dollars, depending on what level of customization you're doing. And to actually build one of these things, you usually mess up a few times. And so the first 2 or 3 are actually not going to work out. You're going to take a couple bets that are too aggressive. They don't work. You're going to, you kind of have to do this stuff in parallel to actually meet any kind of timeline. And so now you're substituting, speed for cost. And so now you have to have, and you need a bigger team of people to work on that. And so you add all these things up, and that's why this hardware is expensive. It isn't that fundamentally it's expensive. So at the end of the day, when the use cases are fully sorted out and the software exists and the market is there, you're going to be able to make these things for, dollars, if not pennies. It's just getting past that initial hurdle where you can get into those volumes. That's been the challenge.
Did you know about this?
And by the way, that's why I think, sorry to interject, but if you mentioned, self-driving cars and LIDAR and things like that, I think that's another interesting topic because yes, LIDAR is very expensive right now for self-driving cars, but there's no fundamental reason for that.
That's just because of volume, you're saying? Again,
yeah, it's just volume. Yeah.
Okay, then do you think Tesla made the right call at that end? Would you have done the same?
I think it was a really smart short-term call, but I think Tesla needs to, I think they ultimately need to kind of go back on that a little bit and say, oh, well, new shit has come to light. There's now an incredible LiDAR sensor that's $10 and it's going to save lives. So yeah, we're going to use it. But I really like that idea that they're depending very, very substantially on vision and camera-based vision. I think you can always just keep making that smarter with better and better processing. And actually, you've seen with the Teslas, they've actually had to upgrade the compute hardware. They've upgraded the neural net acceleration hardware faster than they've upgraded the actual sensors, right? And so, but yeah, I do think eventually, I think there's going to be some clear use cases clear examples where people prove that better sensors do save lives, and at that point, it's very hard to say no, we shouldn't spend $10 more on a LiDAR camera. But right now, it's very easy to say no, we shouldn't spend $5,000 more because now the car is not even, it's not even purchased by anybody, and therefore we can't even justify working on the system. So I think it was the right choice at the time, but I think over the next few years, I think that'll that'll become the wrong choice. And I think it'll make sense to integrate better sensors.
Maybe like also just like you said, that forces you to kind of build this software perception layer out so that perhaps it can work with more inputs, but rather than first relying on like LIDAR to, I mean, they call it like a crutch, but I can see why. Focusing on neural nets is like the more important thing.
Yeah, I can't think of a better analogy, but I think at first it's a crutch, but I think ultimately it's not a crutch. It's a superpower ultimately. Yeah.
Fair enough. Okay. One last question about this hardware and sensors. What is Apple doing with the LiDAR unit? What even is it? How does it work? And what are they doing with it?
I have the same outside in knowledge anybody has about it, but I kind of do know what they're physically what they're doing, and it makes a ton of sense. And I had asked a lot of companies why not do this previously, and we'd even thought about doing something similar to that at Occipital. But again, a small company taking bets like that is risky. But what they're doing is they have a very fast time of flight sensitive camera, and then they have an emitter that sends out light pulses in infrared spectrum, and they've picked the part of the spectrum where sunlight is very doesn't actually emit as much light because water in the air actually absorbs light. So they pick the part of the spectrum where the sunlight actually isn't interfering too much, and of course they can do that because again, it requires a small customization, but at Apple volumes, that's fine, right? So you customize the emitter and the camera to be sensitive to this part of the spectrum. You have a very time of flight sensitive camera, but then instead of doing a flood light where you just flood the scene with light, what they've done is they've chosen to emit light at very specific points, and they used an emitter and this diffractive technology to be able to basically create a point, a spread of points, and to do so in a very compact area. And the way that it's very compact is I believe they've layered a couple of filters on top of each other, which actually shrinks the size a little bit. It results in a bit of a constraint on what the pattern can actually be. It has to be more like, maybe you've seen some of those, you get like a $10 laser pointer and they have those little filters you can put on them that turn the laser beam into like 10 points or 100 points. And you notice the structures that come out are usually very repetitive, like they're the same shape over and over again, rather than a totally custom, pixel wise, pattern. So you end up having this repetitive structure and so on. But basically, they take a laser source, they break it into this repetitive pattern, and then they sense depth at each of those points. And some people might critique that and say, well, that means we only get a finite number of points. Like we don't get a dense depth map. But then when you think about, oh, wait, we have an amazing visible camera on the same device, we can use that to infer, edges and things like that. And so now we can combine this, very sparse input with, this high quality color camera, and we can bring the strengths of the two together. And now we have the advantages of maybe a very high power, very high resolution depth camera with a system that uses far less power and is able to be miniaturized better. So I think they made a really good choice when you combine software and hardware together. But to date, a lot of people have either been coming at this from a hardware perspective or from a software perspective. And you talk to people that design depth cameras, historically, they literally have no idea how the software works, and vice versa. The people building the software just take as a given the hardware that they have, and they don't say, well, can you guys just make a change to the camera exposure, and all of a sudden this problem works now? Instead, they solve it with a crazy neural net or something. Sometimes it's a bit silly how people don't just talk and realize how they can make a joint system optimization. But maybe that's a long-winded answer to what is Apple doing. And so that's my answer.
Cool. How does that compare with the front-facing Face ID?
Yeah.
System? Is it fundamentally similar? But
so the front-facing Face ID system is similar but different. So it's similar in that it has a pattern, but instead of the pattern that's very repetitive, like I mentioned, and very, very sparse, it's actually less repetitive and very dense. But one of the trade-offs of that is that it can't project as far. And so you can't get as far of a range. And instead of actually measuring time of flight or, pulse time for each beam, it's actually just getting back an image, and then it's computing like a disparity on that image, similar to the way a stereo camera would work. That actually works fine in short ranges. But when you go to very long ranges, that starts to break down. If you look at the structure sensor, there's a pretty wide baseline between the projector and the camera. And that's intentional because the wider that baseline, the wider your disparity information is, right? And so we get better precision at range than, for example, the Face ID camera, which only has a very short baseline. But when you use time of flight instead, now your measurements are time-based and they're no longer dependent on that baseline. And so, again, similar in that they're both using pattern projectors, they're both using infrared, but different in how they're actually sensing. In one case, it's a pretty traditional, camera. In the other case, it's a time of flight camera.
Very cool. Yeah, I'm excited to see it on the next iPhone. To see, there's already quite a few apps that have built around first they had built around just ARKit and doing like scene reconstructions from that, but now with the LiDAR, it's just better white walls are being reconstructed. More things. I do have to say the resolution of the mesh at the end is still it's still kind of lacking in terms of what I can still achieve with just images and doing kind of like offline photogrammetry on a PC. Yes. But that just tells me that like the sensor is not so much for reconstruction, like of reconstructing really high quality photogrammetry meshes, but more for AR, more for occlusion, more for just SLAM in general. Is that?
I would say that is more of an artifact of the software that has been created so far than it is about the sensor itself. I mean, we also, if you look at the meshes, the ones you're seeing so far are basically ones built by Apple's meshing API, which that meshing API made the choice to be incredibly low overhead, quite low memory, really, like you said, about occlusion. That's what that API was meant for rather than scanning. Of course, you and I are looking at it as a scanning device. And so we're looking at the results and we're saying, why is this so low resolution? That's more about the API than it is about the software so far than it is about what the sensor can actually do. I think you're going to see probably Apple's going to do some of this themselves, but you're also going to see a lot of other companies, hopefully Occipital too, taking those raw inputs, which are now available. Literally, as of the latest iOS beta, it's now available. But until then, using Apple's meshing was your only option. But in the near future, with iOS 14 release, you're going to be able to leverage that sort of LiDAR cloud directly. When people start to do that, they use that LiDAR cloud directly. They use that high resolution visible image together. They start to fuse like photogrammetry solutions with the LiDAR data. You're actually going to see, I think, the best of both worlds emerge. It's going to use a lot more compute. It's going to be a scanning app as opposed to, it just runs in the background magically for AR. But when you allow it to use a bunch more compute, it's going to be pretty awesome, actually, I think, even with the same sensors.
That's great to hear, actually, that it was more locked from the API side rather than the sensor itself not being able to produce a high dense enough mesh. So. Mm-hmm. Cool. I'm sure a lot of people that are listening that have heard about, we've had a lot of conversations here about reconstruction and photogrammetry, and I always end up kind of recommending like PCVR or PC reconstructions are not going to go away, and I still think they won't because it's just such a scalable platform. You could just throw in images from any camera, any device, a drone, a DSLR in the same project, throw in a couple thousand more, and if you have enough RAM, you can get a really solid result. But that's a very small amount of use cases of times that you'll use that you'll want to use reconstruction. So, I'm extremely excited for a lot more people to be able to scan things.
Yeah. And that's a topic I'm really personally excited about too, is sort of apart from the actual, hardware, what's going on at those layers and things like that. What are the actual users going to be able to do? And right now it's just a few people, yourself included, that can create these amazing reconstructions today and have, and create these memories and be able to revisit them and share them with other people. The average person today just doesn't know how to do that. I mean, they could, but they're not trained in how to do that. They don't know how to. And I think it's a bit of a shame because, it'd be amazing if 10, 20 years from now, people had these memories of these people and places that they were. And unfortunately, they're not quite capturing them today. They're capturing, tons and tons of photos and videos, but maybe in some cases, they're not quite capturing things correctly to be able to create these immersive reconstructions in the future.
Yeah, like especially with videos, you're most likely not going to be capturing a video of your room without a person in the video, right? When you're recording a video, it's almost always of a person inside of the room. So there's an inclusion there. But yeah, I keep on I'd say a bi-weekly to a monthly level, I get a question on Twitter of someone like, "Hey, I'm moving out of my house. What should I do to scan my room?" And I've done my best to try to answer them. I've written some dense documentation on this that we haven't been able to publicly release, but I think that's probably the biggest thing that's missing, is just like good tutorials and documentation for these things. Because the amount of things I've learned through just YouTube tutorials is it's immense. You can be anyone, and you can just learn just by following a step-by-step instruction. And I guess the good thing is that's also going to get easier with better hardware and phones.
Exactly.
Okay, so you're all in on mobile. For you, everything is based around mobile.
Well, the ironic thing is everything with structure and Canvas has all been around mobile. Of course, my new stuff with Arcturus is working with Valve, where at least at this moment it's PC based, right? It's PC VR, it's high end. But yeah, with that notable exception, I'm very big on mobile.
So tell us, a little bit about Arcturus Industries, what you've been working on, and also how the RoomView 3D kind of came around. We're working with Valve.
Yeah. So, obviously, I won't spoil any Valve secrets. I'm sorry. I can't tell you about the elaborate Half-Life roadmap that I, of course, know everything about.
Of course.
Just kidding.
Just say don't say number 3, and you'll be good.
So an amazing group of people at Valve that we've known for probably 5-6 years at this point. Seeing them at different conferences and keeping in touch, and was always talking to them about VR and computer vision and how do those two come together, and so really happy to say that we're working together on that problem now. We have a team. Actually, a lot of our team is based in Madrid. I'm going to be based in Seattle, and we're working on problems at the intersection of VR and CV. You look at companies like Oculus, of course, Microsoft. You see heavy use of CV and computer vision in VR. You see computer vision being used for tracking pretty extensively now. Before that, you saw outside-in solutions with cameras looking at players or base stations set up in the room. Lighthouse base stations from Valve still remain the best way, I think, to track a person in VR right now. But you can imagine there are constraints with that. People would like to see that go away. There's just all these different ways that you can use computer vision to make VR better. There's the obvious ones that we've seen, but there's a lot of less obvious ones that we're going to see over the next few years, and ways that you can make VR more comfortable. I'm sitting in a chair right now. You can't see that chair. What if you could? That actually might be useful, especially if I stood up right now and, where's my chair? I don't know. I'm going to have to do some kind of weird, kicking my leg around to figure out where it is, right? Imagine you could fix that by knowing where a chair is in VR. So I'm not saying these are all the things that we're going to be doing, but these are examples of ways that computer vision can help VR. And of course, AR also benefits in much the same way. Although I'd say today we've seen way more attention of computer vision and AR together because you have to have computer vision for good AR. Whereas in VR, you can kind of get away without some of it. But I'd like to see what happens if we really fully utilize computer vision, SLAM, semantic understanding, deep nets to make the experience in VR that much better. And so Room View 3D is the first thing that we've released with Valve. And the idea there is, you have these cameras on the headset, but they're actually not where your eyes are. They're situated about 100 and so millimeters apart. Your eyes are usually 60 to 70 millimeters apart. They're situated down lower than where your eyes are. And so, if you take a Valve Index or an Oculus Quest from a few months ago and you turn on the pass-through video, what it does by default is just beams those camera images right into your eyes, even though they're not from your eye position. And you put your hands out in front of you and they don't look like they're the right scale. You have trouble like focusing on things, and you have trouble like realizing how far away things are in the room in front of you. And you kind of reach out and you knock over a glass of water or something like that. And it's just very uncomfortable. As a result of it being uncomfortable, the pass-through isn't used all that often. It's only used when it needs to be. Because you really have no idea where you are, so we need to show you where you are in the room. But we don't use it all the time. People don't use it all the time in VR because it's not that comfortable. So Room View 3D is about making it comfortable and doing that by correcting all the physical aspects, correcting the fact that the cameras aren't actually at your eye position by actually first understanding the structure of the scene in front of you and then using that structure to reproject the camera view correctly. So that, when you reach out for a glass of water, it actually is in the right spot. Or you hold your hands out in front of you and they look like they're the correct scale. It's still a work in progress. It's experimental right now, but it goes a long way to letting you do that. And if you turn on the feature, you'll notice that your room is now at the correct scale. Something as simple as the lighthouse boxes appearing on top, the rendered lighthouse boxes appearing on top of where they are in the camera view, they actually generally appear correct now, whereas without Room View 3D, they weren't correct. And so it just really just makes it that much more comfortable. And maybe that's a preview that if now it's more comfortable, maybe we can start using pass-through in a more extensive way. Again, not saying that's the plan or anything, but just you can imagine I'm excited about the possibility of, hey, now that this is more comfortable, can we use it more? But that's kind of the point of Room View 3D.
So what's happening kind of under the hood is some sort of real-time meshing of the room based on the two cameras, and then you're kind of projecting the two cameras' feeds onto this mesh, and that's what you're looking back at.
Yeah, and so and if you were an expert, and if you're sort of really study this area, you can pretty much immediately tell what we're doing. We're reconstructing a mesh of the scene live. We're doing it very, very fast usually at camera frame rate. And then that mesh is immediately used and the camera view is projected onto that mesh. And, the ways that that'll become better is making the mesh better, improving the quality of the, the raw camera feed itself so that there's less noise and things like that. And, making it maybe faster and more responsive. But yeah, those are kind of the dimensions that should make it more comfortable and more correct over time. Because it doesn't have active depth, it does struggle in some cases, but we've made some interesting smart trade-offs so that even when you look at a white wall, it's estimating depth there, and it's doing a good enough job that typically you don't become distracted by that.
If the stereo cameras were originally planned for pass-through by Valve, which I thought I predicted it would be, rather than some sort of an inside-out positional tracking device, which doesn't make sense with the lighthouse infrastructure being built out and whatnot, and that still works out incredibly well, especially when you have multiple things that you're tracking, peripheral devices and whatnot. Why did they end up having the positions of the cameras be wider than the typical eye distance?
I obviously can't comment on that, but not because I in part not because I shouldn't, but also just because I don't purport to know all their all their decisions and why.
Fair.
But it is a good point. If the cameras are going to be used for pass through, why not put them right close to where your eyes are? If the cameras are going to be used for something else, okay, maybe that makes sense. But why aren't they used for something else? So yeah, that's a good point. I will say one thing though that they did choose to do on Index was to have that open sort of frunk area where you can attach another device, like maybe a Leap Motion or another camera or some other kind of cool accessory. If they had put the cameras there, they wouldn't have had the space for that there. So maybe that was part of the logic, but I won't speculate any further.
Fair. But maybe we can even think of it, but since the spacing is bigger than any sort of like meshing, like the distance between the cameras being larger than IPD would give you better depth, like even millimeters would make a difference.
Yeah, that's true. Like the wider the baseline, the better, certainly especially for things that are farther away, we're going to be able to do a better job of estimating their distance. Now, for things that are really close, there can be problems because maybe you can't even see that on both cameras. And if that's the case, then how are you going to estimate depth? But for things that are farther away, yeah, we're going to get better accuracy because those cameras are wider apart.
I've been I was very excited when they announced these cameras, and they're very like developer focused. They have global shutters. Like there's a lot of like features that aren't just like thrown together. They're not just cameras that are thrown onto the headset just for the sake of it. Yeah. Have you seen any interesting applications beyond like what you guys did at Arcturus that is, that's notable or that you want to mention? Perhaps why, if there hasn't been, like, why do you think people haven't done much with it? Or what do you think?
It's a good question. I think I haven't actually seen much. I'm sure there are things, but there's nothing that's sort of risen to the, to a very high level. There's this guy, Sean, who's working on an engine called Particle Engine. He's based in Seattle. We're sort of friends with him. I know he's been using the cameras to try to do scene meshing, and I think there's been a few experiments here and there. I don't really know why. I think part of it comes down to, maybe there aren't a lot of developer examples out there for people to get started with, and maybe we could help by creating some. I also think that you now have like a supply demand problem with people that know how to build this kind of stuff, right? You have platforms like mobile devices where you have, billions of phones out there in the world. And then you have VR where we're still in the hundreds of thousands, low millions. So if you have, to choose a platform to put your time towards, is it going to be that system or is it going to be, a phone? And I think a lot of the people that know how to do this are making that choice, and or they're employed by, a company that's telling them to do something else. So I think that's a lot of it is just the supply demand of the developers that can do this stuff have another more lucrative platform to work on. Is unfortunately, I think, part of it. But I think, lack of great samples and things like that probably plays a role too.
Yeah, fair. Plus, I feel like the low-hanging fruits are the sort of scene meshing and stereo correction things which you're doing, and so the harder things are harder. And in terms of unit sales, it's like VR headsets are into hundreds of thousands to low millions. Index headsets are probably like way less. God. I
think I don't know. I think they're doing pretty well. I don't know what their numbers are. I think they're among the best, but yeah, they're still not, nowhere near what a phone deployment or, what a successful phone deployment is. Right. And so, yeah, I think that plays a role, in people deciding what to work on, unfortunately.
Okay. So final question. Do you see VR, the headsets in the industry, creeping up more into what the AR territory and its use cases are, more than the opposite, which is AR headsets kind of being the larger circle that encompasses the VR use cases, which is what I feel like what the narrative of AR has been since like 2015, 2016, which is AR, it can be the more inclusive thing. It can do VR and AR, and VR headsets are just limited to being, in an immersive virtual space. And perhaps do you see your work kind of helping that along in that sense?
I would definitely like to see VR bridging into some AR cases. I think to answer your question of which one's going to happen more, I think it's probably more that over a 10-year horizon, it's going to be probably more that AR creeps into VR, because AR does have the potential to be more day-to-day all the time. It's going to take a while though, right? Like I think people underestimate how difficult it's going to be to make an AR device that's truly comfortable, that doesn't have a compute brick that you need to have somewhere, that, you know, that can actually run all day long. Like that's really hard. Like even if we can pull off, you know, the tracking and the display and all this stuff, can we do it all day long without a huge battery? And the answer probably for another 5 or 6 years is going to be no, not yet. So you're going to have things that you only use for shorter periods of time, maybe to capture a clip here and there, maybe to get some information just when you need it. It's not going to be on all the time. And so until that happens, though, I think AR is not going to be something that every person is using. But once you get to the point where that has been solved, then I think you're going to see, you know, people consuming VR type experiences through the AR devices that they're already wearing. Yes, I think that's going to be the bigger number of people. But I think the other way around, VR devices doing some AR things is a much lower hanging fruit. It's something that we can actually start to address now. And it's something also that's not going to go away, actually. I don't think it's going to be subsumed by AR, because at least I haven't seen any AR technology that can simultaneously be incredibly comfortable, lightweight, see-through, but also fully immersive, right? That just doesn't exist until there's some kind of neural implant or something crazy. You're just not going to have that, right? You're going to have to literally put a headset on, or some kind of blackout thing to be able to have the full immersive experience that you get with VR. So I think you're still going to have, maybe for 20 years at least, you're going to have devices that are either AR or VR. They're going to be lightweight. They're going to be cheap. You're going to have a bunch of them sitting around. They're all going to be connected. They're all going to be able to consume and interact with, you know, a persistent spatial, you know, configuration. I put one on, you put on, boom, we're in the same environment. Why shouldn't that be the case? Like, why do we have to literally connect over the internet to do this, right? It should work if we do it in our house as well as, you know, over the internet. So you're going to see that happen. But then you're going to have a continuum where there's a lot of experiences that are, you know, you have an AR device on, you can still kind of do a VR thing. You have a VR device on, you can still kind of do an AR thing. There are some cool things that you can do with VR device that you kind of can't do at all with AR, which is completely change the environment, right? With AR, it's very hard to change something. You can add something. You can kind of sort of hide something, but you can't really truly change something. And you can't really show someone like, hey, here's what it looks like if the lighting is completely changed. Like those are things, just forget about doing that in AR, but in VR you can do that. And there are use cases for that, right? If I'm in my living room and I want to say, hey, what if I redesign this whole living room? I should be able to talk to an AI system that can, you know, take the scan, convert it to CAD, modify it, show me what it would look like at any time of the day. You know, I want to be able to do that. And I don't see that happening in AR. And then as well, I think there's a number of use cases around gaming where if I put my VR headset on, do I instantly want to be dropped into a completely different environment? Or would I rather have there be this continuum where I put the headset on, I'm actually still seeing some of the world around me. I can continue to get myself situated, get ready for my game. I can see some of my trophies and games like floating around the walls with me. And then boom, I hit a button and now I'm immersed into my game. I think that would be a better bridge into VR than what we have today.
Sure. Bridge is a funny word to use also, yeah. From the Occipital. In terms of, if you want another data point in terms of VR not going away, or at least like with VR doing a lot of AR use cases and that not going away, PCs are not going away, and Steam and Steam VR, like these are growing platforms, which if you look at PCs, like that gives you unlimited quote unquote, unlimited amounts of power with no battery. And like that will only get more powerful. And so it's the same reason why, like, you know, 15 years ago when people were saying consoles will kill PCs for gaming, that didn't happen because PCs were always like 2 steps more powerful. And it also kind of grew into this cultural thing of like this rite of passage of like building your PC and customizing it. And so I think that if you just look at that trend, like that will for sure not go away. And perhaps there might be use cases of things that just don't exist on AR headsets would always be a couple of years behind in that sense.
Yeah. I mean, you look at what you can do on a PC, like you can take 2 or 3 GPUs that are massive because of just how much heat they dissipate. And then you can stick them in there and you can use 1200 watts if you want. And you can deliver an experience that is essentially, it's a time machine into 2 or 3 or 4 years into the future of what a mobile device will be able to do. At the same time, there is a weird trend, which is if you look at the compute power of a mobile processor versus the compute power of a desktop processor. I actually charted this last year, and I noticed that the gap had been being bridged. Like when I first started developing on the iPhone, there was this rule of thumb which was like 10 times slower. Like if something was going to run on your CPU core, you should assume it's going to be about 10 times slower on the phone. But then that became 9 and 8 and 7 and 6 and 5. And as of basically last year, the amount of time that a tight loop would run on your high end, Intel laptop versus your phone was actually about identical. And the only reason that the laptops were still winning is because they had like more cores and they could just dissipate more heat faster than a phone. But you're seeing that being bridged too. And then you saw Apple say, a couple of weeks ago, hey, guess what? We're going to use Apple Silicon in our next laptops. So, and that, like the writing on the wall was there for me, which was, it was pretty obvious that was going to happen. And that's just a testament again to when you have, a market where people are literally going to buy billions of these things, that's a lot of motivation to make this stuff, faster and cheaper and smaller. And so you've seen this incredible, shrink in the transistor technology that powers these phones to the point that they're using like 7 and 5 nanometer, gate devices, and PCs haven't caught up yet. So that's one weird way where this trend isn't quite playing out. Like we're actually seeing mobile devices in some cases be faster. But then, Apple's going to say, okay, cool. You know what? We'll just go ahead and put that in the laptop as well. Hopefully others will follow suit and will catch up. I hope, Apple, I think, is in the lead in terms of how fast their chips are, but, Qualcomm is maybe a close second, and, there's other contenders. I'd like to see that, continue to play out. I'd like to see people build more power efficient mobile or desktop processors as well, so that, desktops can again, like leap ahead. But, go and run a Geekbench on your latest, PC that you probably think is 10 times faster than your phone, and then look at the numbers and realize they're actually not that different. Where they are different, though, is on the GPU side. They're still very, very different. And what you can get a, NVIDIA RTX, 2080 Ti to do versus what you can get a phone to do is incredibly different. And that's the place where PCs are still really a time machine into the future. And on the processor side, I hope that the CPUs catch up. I think they will. But it's kind of a bummer now that your desktop CPU and your phone are about the same speed. But, it's not going to be, I hope it's not going to be that way a couple of years from now when, maybe more of the ecosystem switches to more power efficient ARM processors, and then PCs can surge ahead again. But I agree with you. PCs aren't going away. And I think the reason for that is they are kind of a time machine into the future, and nobody's going to give up that time machine. I mean, how much of a niche they are is going to vary, but they're not going to go away.
Yeah. No, that's fair. We could also even talk about that we might be completely ignoring like streaming becoming, like adding that into the equation when it comes to mobile, and like how, like, today, like Google Stadia and whatever Xbox thing is, they're in their very nascent form, but like fast forward 10 years, 15 years, maybe they'll be at the point where it's suddenly giving mobile a leg up in some things. But yeah, there's a lot of reasons past that why PCs and just doing local compute will never go away, especially on like the development side.
I sure hope they don't go away. You're right though. I mean, that is another small threat, and I think there have been a lot of small threats that have chipped away at how pervasive PCs are. I mean, they're still very, very pervasive, of course, in the business world and so on. So that's one reason, but I actually don't know the numbers, but I would suspect that there's probably less PC usage as a fraction than there was, a decade ago. But yeah, like where does it fall down to? And I think it's very much the case that the PC world can react quickly, but it does need to react. It does need to show, no, here's why we're actually better. Like, here's what we can actually do that you forget doing on your phone. They need to keep that in mind. And maybe be less of just like, hey, we're yet another device. And like one of the trends has been like, oh, PCs are just another device now. And so they're just the same. And for some users that makes sense, but if PCs want to have a long-term life, they need to be more than just another device.
Fair. Awesome. Jeff, how can people find out more about you and about Arcturus Industries and perhaps ask you any questions?
They can email me at jeff@arcturus.industries. They can also just tweet at me, JRPowers on Twitter. And I'd love to hear from people. We didn't talk a ton about it this time, but the topic of making, photogrammetry and reconstructions like that more pervasive, making it so that people can capture their memories, without a whole lot of training, without having to maybe go through as many of those tutorials, without having to be an expert. That's something that I'm particularly passionate about on the side. So that's sort of a personal passion. I'd love to talk about that. I'd also love to talk about, computer vision and VR coming together, and what are some of the features people would actually like to see happen. We talked about, of course, tracking. We talked about understanding of some objects in the room. But what else? So those are all things I'd love to hear from people on.
Awesome. Well, thank you for joining us.
Yeah, thank you. Thanks for having me. Love to do it again sometime.
Thank you all for listening, and goodbye.